Everybody, here's your bell ringer for the day. Please work through these for a little bit and then have the sub press play and resume the videos. Alright, so please press pause for a little bit and have the students work through these three bell ringer. Alright, so we're back at it. We got to state the domain and range of the first one there. So remember, we're looking for where the asymptote is in the function to find that a little bit. So we have domain. Think about what the domain was for all of our exponential functions. It's always all real numbers. And then the range depended on the asymptote. Okay? So it's always back on the back end, right? The asymptote's on the back end of the function. So it's always plus something or minus something. Here we don't have anything, so it's plus 0. So then we have to say, is it greater than or less than? And then this right here is going to tell me that. So negative numbers in front mean it's going down. So y is less than 0. So that's my domain and range for this function up above here. Second one here, we're going to state the domain and range and then graph it. Okay, so is this, let's just kind of throw a random question in here. Is this going to be a growth function or decay function? What did I say about having a fraction inside it as a base? So that's decay. That doesn't really affect our domain and range, just kind of a question to throw in there. Domain, all real numbers. And range, do you have plus or minus something on the back end? We don't have anything, so it's like a plus 0. It's not the exponent. We don't look up there. We look on the back end of the function. So this one's going to be y is greater than 0. Because we have positive numbers in front and we don't have anything on the back end. So we need to do an XY chart, and -2 to +2 will work here. Remember, if you want to try, if we have a different function, then we always look up here. So we would pick numbers around 1, so we could do -2, or -1, 0, 1, 2, 3, so where 1 is the middle number. We'll just go with it here. So -2 goes in the exponent up here for the x. So -2 minus 1 is the -3. So we got 3/4 to the -3 power. So that means it would flip it and cube it. So we're going to have 64 27ths, not ninths, 64 27ths. Okay, the next one, if we put a -1 up there, we'd have a -2 in our exponent. That would give me 16 ninths. Okay, and again, these are pretty ugly numbers, so decimals might be the way to go here. The next one would be 3/4 to the -1. That's 4/3. 3/4 to the first power, or sorry, 3/4 to the 0 power would be a 1. And then the next one would be 3/4 to the first power, which is going to be 3/4. And we could continue on, or we could just know that this is going to level off at 0 because our asymptote is plus 0, okay? So if we graph the function, it looks about like that. If you wanted a little bit better numbers, if we use like a -3, -4, we can kind of get that part of the graph where it starts to kind of really zip off into space there. Okay, -6. Remember, it doesn't really matter what points you plug in. You can plug in 10 points, you can plug in 5 points, whatever you need. We got to do at least 5 though, whatever we need to get a good graph. Okay, so I can highlight some of the points that we have. So 0 4/3 is right there, 1 1 is right there, and 2 3/4 is right there. Those are the points that we had. The ones that I have off to the left, we didn't find those, but it wouldn't take much work to find those. All the way at the bottom, the function p of t equals that, gives the value of a type of car after t years. Find the value of the car after 10 years. All right, this is a decay model. And I know it's a decay model because the stuff in the parentheses here is less than 1. And if you use a little bit of common sense here, think about what happens after you buy a car. As soon as you buy it and drive it off the lot, it goes down in value. So we're going to find the value after 10 years. So 10 is my t, so we're just going to plug that in. 0.88 to the t power, which t is going to be a 10 here. So then you're going to take your calculator and just plug that in. So we got 12,995 times 0.88 to the 10th power. And that gives us 3,619 and 12. So that's a dollar amount because that is the value of the vehicle. Okay? So that's not very much. We bought the thing at around $13,000, had it for 10 years, and now it's only worth $3,600. All right, that's welcome to real life depreciation. You buy a vehicle, the value goes down very fast, okay? So there are your bell ringers. I've highlighted a few homework problems here that we can look at, so please get your homework out, and we got 5 problems here that I'll take care of. If you want to skip over one, then just ask the substitute to skip forward a little bit, just to save a little bit of time. So I kind of looked at the word problems first. So 20 is a graph. We can come back to that one just to double check it, but number 19, 26, 27, and I think I have 28 down below. Those are all kind of the word problems. Those are the harder ones, the real world stuff here. So we have a beetle colony. Remember I said this is very applicable in biology, especially with bugs. The colony is growing 30% each week, and we have an initial population of 65 beetles. We want to make a graph of that. Okay, whenever we're working with real world scenarios, exponential growth and decay, you're just going to have like the top right hand portion of the coordinate plane where the bottom is time, and on the right hand side, or left hand side, excuse me, that would be our population. So time on the bottom, population on the top, or on the left there, and we're going to graph it. So we need to make an equation first of all. Remember we had this formula yesterday. And I know it's this formula because it's growing. That's the growth model. Okay? So when we plug in 0.3 and our initial population, we get this equation. Okay, so 65 is the initial amount, 30% or 0.3 is my rate of growth, and I don't have a time because that's what we're going to have to use to graph it. Okay? So let's just kind of go by twos like we did in class the other day and get a decent graph here. So 0, 2, 4, 6. Sorry, we can throw an 8 in there. I didn't realize I skipped it unintentionally. So 8, 10. And you should be able to just plug this in your calculator, okay? So go ahead and get your numbers while you're starting to work on that. I'll get mine, and then we will write them down. Okay, so we start out with 0, so that's 65, right? So anything with a 0 power, this would turn into a 1 here. So 65 times 1 would give you a 65 again. And when we plug in a 2, we get 109. Let's just go to the 10th place, 109.9. 4, 185.7. 6, we get 313.7. 8, we get 530.22. And then 10, we get 896.1. Okay, all right, so then we're going to try to graph this. The x-axis or the time axis, we can go by twos just because that's what we did in our function. So 2, 4, 6, 8 to 10 out here. We could do more if we wanted to. And then the population axis or the y-axis, I would probably go by 100 just because we're going up to 896. And I'm kind of running off into my other stuff up there, but that's okay. We'll make it work. So 100 is what I'm going by here. So there's 100, 200, 300, 400, 500 is up here. So let's go ahead and graph it. So 0, 65, we're in there somewhere. 2, 109, kind of in there. 4, we're at 185, up there. 6, we're jumping up to 313. So 6, we're at 313. 5 or 8, we're at 530. Okay, so that would be around here. And then 10 is 896.1. 2, 4, 6, 8, 10. 891 is somewhere up in there. So we can draw our function like that. So that is the graph of the beetle population in number 19. Okay? So next question, we'll jump to 26, we'll come back to 20 here quick if we need it. If you don't need it, just kind of skip ahead and turn your homework in. But we'll finish these 3-word problems and we'll go to 20 after that, all right? So number 26, we have a basketball team that must not be doing so hot. Their population, or the amount of people going to the basketball game, declines by 5% per game. And we have to make a graph of that. Okay, so again, we just have this portion here. And we have to use our formula here. If we are declining, that would be a decay model. So we're going down by 5%. Okay, so let's just write out our formula. Our initial amount, 23,500. And if we're going down by 5%, that's 1 minus 0.05 to the t. Okay, so 1 minus 0.05, and I'm just going to rewrite that as 95, just after I showed you guys that. So it'll be 0.95 to the t. So that's the function you want to graph. Okay, so I would kind of do the same thing that we did just on the last one, where you go by twos. And it actually tells me that this lasts for 15 home games. Okay, so if you went by twos, that's okay. If I want to cover up to 15 games, then it might be best to go by threes. Okay, because we'll go up to 15. So 0, 3, 6, 9, 12, 15. Okay, because the model that they're giving us only goes for 15 games. So I'll get you guys your points for those. So 0, that's our starting amount, 23,500. And then at 3, we got 20,148. At 6, we got 17,275. And then at 9, we have 14,811. 12, we got 12,698. And then 15, after 15 games, we're only down to 10,887 people. Now, it's not going to be the best to graph these numbers, okay? You're going to have to estimate. I don't expect these to be perfect, okay? So let's use our time on the bottom. We want to label this graph, that way we know what we're doing. And this is people in attendance. We'll just say people for time's sake. And then the bottom, the x-axis, will go by threes. So 3, 6, 9, 12, 15. And then try to figure out what we want to go by here. Since we're kind of fluctuating from 23,000 to 10,887, I would probably go by 5,000s. Okay, so we'll say that this one's going to be 5,000. 5, 10, 15, 20, 25,000. So 25K up there. That's what I would do. Now, there is no right or wrong. You can go by 1,000s if you want to, but that means we'd have to have 23 little marks. So I think 5,000 is the best. You could go by 2,500, either way. So at 0 hours, we are around 23,500, which is kind of up here. And then at 3 hours, we're at 20,000. Okay, right there. 6 hours, we're at 17. So 17 would be in there-ish. And then 9 hours, we're at 14,811. So that's here. And then 12 hours, we're at 12,698. So that's here. And then 15 hours, we're around 10,000. Okay, so it kind of looks like a line. It's a little curvy. Okay, I just kind of connect the dots and continue the trend going down. Since the numbers are so large, it's kind of hard to see the exact decay of the function, but you can kind of see a little bit of curvature to it. If you would graph this function here, if you threw it in Desmos, right, Desmos graphing calculator, which you guys can use to double check your work here. If you put that in Desmos, then you would see the graph. Okay, 27, that's the next one. So 27, we have skating, people going to inline skates, I think. All right, so this is since 2004. We have this function here, 3.9 times 0.9 to the x. I think there's a typo there. I think the x should be out there. Okay, so I think it's P of t. If not, that's what we'll go with. 3.9 times 0.09 to the x power. So we have to figure out what the intercept, what the y-intercept here is, and what the asymptote is. So asymptote's pretty easy, like plus 0. So that's y equals 0 asymptote. And then your intercept, your y-intercept, think about what the values are for x and y at their intercept. I'm always going to have 0 comma something for my y-intercept. So if I plug in a 0 for the x, then we'll get 3.9. Okay, so those are the two pieces of information that we need. The question is, and I skipped the first part, it says classified as growth or decay. Okay, we should know at this point that that right there is my growth or decay rate, and since we're less than 1, that's a decay model. So A is decay. And then B is asking what the intercept and asymptote mean in the situation. Okay, so my intercept, the 3.9 here, that's just a starting amount. Okay, that would be my starting amount of inline skaters. And it doesn't make sense that it's 3.9 because you're not going to have 3.9 people, so it's probably in millions or something like that. Yeah, skaters in millions. Okay, so that's I have 3.9 about million skaters starting out, and then the asymptote. All right, so the y equals 0. That is the amount that we'll get close to, but we'll never touch it, right? So that says we will get really close to 0. So according to this model, we'll never actually have 0 inline skaters, but it'll just get closer and closer to 0. If you think of, you guys might not know it much in this generation, but when I was growing up, they had skating rinks, and you can probably find some, kind of like ice skating rinks, but they were indoor just for regular skates. But there are not very many around anymore. Okay, so that's the information for 27. 28, it says, it's talking about medical uses of this. So we have 10% of a drug that dissipates, or actually we have a drug, an unknown drug that dissipates 10% each day. Okay, so identify this as growth or decay. So that would be a decay, obviously. Going to dissipate. So it's a decay model. And then B says how many do we have, or how much of the original amount remains after 9 days. Okay, so we're going to have this equation. That's our decay model. Okay, we don't really know what the initial amount is. Okay, but think about if you take some Tylenol or something like that. Most of the time you take a whole pill. Okay, so that would represent taking 1 pill, right? So let's just say that my initial amount is 1 pill because that's all I took. Okay, so 1, and then we have 1 minus R, and R is 0.1, 10% to the t power. So our equation is really the 1 times anything doesn't make a difference, so it'd be 0.9 to the t power, or x, whatever you want to call it. So that's the equation to model the situation. So we want to figure out how much is in the system after 9 days. So we're going to use that, plug in 9 to get the answer. So if you do that, we get a little bit less than 40%. So let's get an exact number for you. So 0.9 to the 9 power, we got 0.387. So we got about 38.7% of that remaining. So if you took 1 pill, you got a little bit more than 1/3 of the medicine left in your system. Okay? C, it says if the second dose should not be taken if more than 50% of the original amount is in the system. Okay, so you don't want to take another pill if you got more than 50% in your system. So that's why they have on medication bottles not to take Tylenol unless every 4 to 6 hours because of the way it breaks down in your body. Okay, we got to figure out when we can take the next pill. So if we know that that one is 9 days. So let's kind of work back from there. So we're just going to plug into this. Let's check out what we get at 8 days and 7 days. We'll see when we hit it. Okay. So if we plug an 8 in there, 0.9 to the 8th power, we get, this one gives me 43% or 0.43. All right, 43%. It looks a little bit better. And then we plug in 7. We got 47.8, so we're getting closer to that 50%. Let's check out 6 just to see what we get. We get 53.1%, okay? So we can't take another pill until there's less than 50% in our system. So if we're looking at the information we have right here, we can't take another one until we've had that for 7 days, okay? So this might be some high caliber medication that they're using for somebody post-surgery or maybe some chemotherapy or something like that, okay? They wouldn't be able to take it or have another dose of the medication for 7 days. That means a week, okay? So this is really applicable in the medication world as well. All right, so going back up to number 20, we're going to graph that one for you. I'm going to kind of cheat here and go to Desmos. That way we can kind of see how to use Desmos. And if you want to do it by hand, that's fine. So we go to Desmos.com, and you can see we can get the XY charts off there as well. That's what I want you guys to have. Okay, so we go to Desmos. We got the book handy somewhere. That way we can get the function off from the book. All right, and I don't want you guys to sketch these. I want you to actually plot the points. Okay, so we're looking to do number 20. So I have a -4 out front. I got a 3/5. So 3 divided by 5 is the same thing as 3/5. Okay, so make sure you go out to the right when you're closing your parentheses off. And now we have an exponent of x plus 4. So we have to go down to our little keyboard here, press the exponent button, and we do x plus 4. Oops. And it looks like it's not letting me do that, so we're going to have to put that exponent in parentheses. Like that. So I told some of you guys that we had to do that yesterday in order for it to work. And then we'll do plus 3. Alright, so right there is what the graph should look like. Wouldn't be too terrible. We know that our asymptote here, so we got y equals 3, that's where it's going to level off. The negative in front means it's going to go down. I have a dilation or a stretching factor by 4. Okay, and then remember this stuff right here, that's going to translate my graph left 4 units. So, we need to pick points around a -4. Okay, so we don't want to use these points, they're not very good. So let's do -6, and then -5, -4, -3, and -2. So these are the points that are best from -6 to 2. You should get a decent graph from those. Okay, and Desmos gives you pretty much everything you need already, so that would be what you have. So looking at that is not the best. So you might want to do like a 0 just to see what you get. So then you can really kind of start to see where it curves, and you guys see when I put these points in here, it shows up there. So when I type 0, boom, got a point there. Since I got Desmos, I might as well just do it. Okay, if I put a 2 in there, I get about 2.8. So you can really see where it starts to level off. Okay, so here's your XY chart. You can get the same thing with a calculator or a graphing calculator if you have one. Okay, so now your homework's done. Make sure you turn it in. Make sure your name is on it, and we'll get started with the new stuff. Okay, so get up and turn your homework in, please, and we will get started on the new stuff. All right, so the 6.2 is what we're doing today. We're solving exponential equations and inequalities. Not too bad. So it's a little bit of a jump with our brain here, but it's not too bad. So we're going to be able to solve exponential equations and inequalities in one variable. That just means using either just an x or just a y. And then we're going to be able to model situations with exponential equations and get compound interest. Okay, very applicable to real world stuff here. So starting out, we got a key concept. So this is what we're going to kind of use to help us solve. We have something like this. If b to the x power equals b to the y power, then x equals y. So that's pretty much saying if you have the same base, then you set the exponents equal to each other. Okay? If you got the same base, then you can set the exponents equal to each other. That would equal that. Okay? Once you got that written down, write down the next two little mini examples here and we'll work through them. Okay, if I'm looking at A here, I got 3 to the 7th equals 3 to the x. So what does x equal here? Should be pretty self-explanatory. If I got a base of 3 on both of these, I can kind of forget about it. And I got 7 equals x, or x equals 7. Okay, because that would make sense if I put a 7 in there. 3 to the 7th equals 3 to the 7th, right? That's like saying 5 equals 5. It makes sense. Okay, so the next one here, m to the 6 equals m to the 2x. A little bit more complicated, but still not bad. Okay, so you can kind of look at that and say, well, I should have a 6 up there, so x has got to equal 3, right? That's just by looking at it. But the way we want to kind of get used to doing these is making a little equation with the exponents. So if I have these bases that are the same here, I can just kind of forget about them, and I'll have 6 equals 2x. And then how do you solve for x here? I divide by 2 on both sides, and boom. You get x equals 3. Okay? That's the idea that we want to kind of follow for the exponential equations and inequalities. It works the same way for both of them. All right, let's check it out. So the strategy here, since we don't have the same base, we don't have a 3 on both of those, that's the strategy. So we're going to find the same base. And then set the exponents equal to each other. Okay, set the exponents equal. So we're going to think the simplest base. So looking at the 9 over here, 3 is as simple as it gets right there. 3 is kind of the smallest number. I can't break that down. Think of the 9 as like factor trees. What would you break the 9 down into in the simplest form? Okay? Or can I rewrite the 9 as a power of 3? Okay, so looking at this, that's like 3 to the something. What does 9 turn into? That's 3 squared, right? So we know that 9 is 3 squared. So let's rewrite the 9 as 3 squared. But then we got to keep that 4 on the outside. Okay, because that 4 was there, we can't just get rid of it. And then on the left here, we have 3 to the x. So does that give me enough information to figure out what x is going to be here? Well, I can kind of forget about the bases, and then right here, when you got those two crunched together, when two things are crunched together right there, you're going to multiply exponents. Right? So let's set these two equal to each other. So we got x equals 2 times 4. That means x is going to equal 8. And there's something really nice happening with these because you can check your answer. If you use a calculator, plug it in. I'm going to do 3 to the 8th power and then 9 to the 4th power. See if they give me the same answer, which they will. So that means they're going to work out. Let's try one on our own here. Okay, so we have 2 to the 5x equals 4 to the 2x minus 1. So think about what is the simplest base we're going to write this as. Can I break 2 down any further? No. Can I break 4 down? Yeah. So first I want you guys to rewrite it both as powers of 2. Okay, so take a couple seconds here, write it down as both as powers of 2. Right up here we did powers of 3. So below we're going to write it down as powers of 2. So this is what you should have written down. So a 2 to the 5x, I can't break that down anymore, I leave it. 4, I'm going to break that down into 2 squared. Right? 2 squared is the same thing as 4. And then I have that 2x minus 1 floating around up there still. So from there, I can forget about the base. And then I just multiply in the exponents here. So I got 5x on the left, and I'll have 2 with the 2x minus 1 on the right. So then we can solve there. Okay, so 2 distributes, gives me 4x minus 2. So then we got to get the x on the same side. So I'll move the 4x to the left here by subtraction. That's going to give me just an x on the left. So we get x equals negative 2. All right. So you want to think about the simplest base. What can you break it down into? Can you break it down into a smaller answer? You can never make it a number larger, okay? We can always just kind of break it down. If I make a number larger, then you're just pulling stuff out of air, okay? So that 2 has to stay as a 2. So we can double check our answer here. So if I plug in the negative 2, I'm going to get 2 to the negative 10th on the left, and I will get 4 to the negative 5th on the right, which you can plug into a calculator and see that you'll get the same thing. Or I can kind of think of my properties where I break the 4 down, so that would turn into 2 squared to the negative 5th, which is 2 to the negative 10th. So I'd have 2 to the negative 10th on the left and on the right, so that would work out. All right, hopefully that makes a little bit of sense here. We got a couple more that we're going to try. So let's try B here first. Okay, so please pause the video, have students work on B, so give them about 2 to 3 minutes, and then press play again and have it work through the example for them. Okay? So let's go through B here quick. So we want to break these down into the simplest form. Now you're like, well, I'm going to make the 9 or the 27 into a 9. Well, we have to think of powers. Can I rewrite these as a power of something? Okay, I can take 9 times 3 to give me 27, but you're not going to multiply stuff. We're working with exponentials here. So I'm going to rewrite the 9 as a power of 3 because that's the simplest form or the simplest base I can break it down into. So the 9 would be 3 squared, and then we have the 2x hanging out there still. The 27, that's going to be a 3 cubed. And then we have the x minus 1 up there still. So we got the same base here, so let's just forget about it. So on the left, we're going to have 2 times 2x. And on the right, we're going to have 3 times x minus 1. So from there, just simplify. So we'll have 4x here equals 3x minus 3. Because that 3 distributes. Okay, don't forget the 1. You got to distribute the 3 into that. So move the 3x over. And we get x equals negative 3. Okay, hopefully we all got that answer. If we didn't, you can always come back to the video later and see where you went wrong. So I want to go back to A here quick because we have a fraction in here. You guys probably saw the first one with the fraction and you're like freaking out a little bit. It's not too bad. Okay, think about the simplest base here. How can we rewrite this as a power of something? Okay, 4, we just got done doing that not too long ago. So we can write that as a power of 2. So 2 squared. And then we got the x there. Right? So can I rewrite the 1/2 as a power of 2? I see a 2 in there. What power of 2 would give me a 1/2? Well, that would be 2 to the negative 1. Okay? Now, you're thinking here, well, Mr. Hendricks just said I can't make the number bigger. Well, technically, you can't make the number bigger, but we maintained it the same. Because 2 to the negative 1 is still a 1/2. I didn't change the problem at all. If I multiplied it by a number in there somewhere, then I would change the problem. But I didn't change the problem. I just kept it. I just rewrote 1/2 as a different number. Okay? So 2 to the negative 1. You got to keep negative exponents in your toolbox there. So from there, we can go ahead and solve it. I'm going to have 2x on the left. On the right, I'm going to have a negative x plus 3 because I'm going to distribute that. So then we can simplify, move the x over. We're going to get a 3x equals 3, so x equals 1, which you can check that by plugging it in. Okay, so that is solving exponential equations. You're going to rewrite the base as something to a power, and then set the exponents equal to each other. That's the goal here. Okay, so let's try one more on our own. Actually, let's try one more on our own, and then we will jump ahead here. So let's do B. So solve the equation there. See if we can get that one down. So please pause the video again, give the students 2 or 3 minutes, and then resume the example. Okay, so thinking of the simplest base, we want to write it down as, this should be pretty quick here. So 3 to 2x, that just stays as the 3. And then the 9 should be a 3 squared. And then we have 5x minus 4 hanging out up there. So forget about the base, set the exponents equal to each other. That 2 will distribute. And then put the x's on the same side and keep the numbers on their own side. If I subtract the 10x, we'll have negative 8x equals negative 8, so x has got to be a 1. But again, you can plug in to double check your answers here. All right, so you can save yourself some errors. So we have this next, and then I think we'll take a break. Yep, so let's go through writing an exponential for the graph here. So we have 2 points that were given. We got 0, 128, and 5, that's a whole number by itself, 371,293. So we want to figure out the equation of the graph that goes through those 2 points, okay? Now I didn't explicitly say this yesterday, but this is an equation that we're going to be using. A times b to the x. This is really the most basic form of an exponential function, okay? Yesterday we had this. We had y equals a times b to the x minus h plus k. We had all that stuff, right? We had the h and the k. Well, I don't really care about the h and the k anymore because I want the most basic form of an exponential would just be a times b to the x. The h and k are the transformation pieces, okay? So let's see if we can figure out our equation. If you are given a point that has a 0 in it, that's the first one you want to use. Because anything with a 0 in it kind of simplifies stuff down, right? So let's use it. This is my x, this is my y. Let's plug it in. So I got a 128 on the left for the y. I don't know what a is, nor do I know what b is, but I got a 0 up there. So anything to the 0 power is 1. That means that guy is gone. So we get a equals 128. That's a piece of the puzzle. Now we're going to utilize the second set of points with the a. Okay? So this one we're going to use next with this. So we have 371,293 for my y value. The a, we just figured out down here, is a 128. The b we don't know yet. We got b to the 5th. Okay, so now we got to figure out what b is. So this is just like the stuff we did last chapter, so you can't forget about it. So we want to get this exponent by itself, or this exponential by itself. So let's move the 128 first. So divide by 128 on both sides. Have your handy dandy calculator ready. So do 371,293 divided by 128. And that's going to give us about 2,900. So I'm going to use the entire decimal in my calculator, but if you rounded, you'd get that. Okay, so we got 2,900.73 equals b to the 5th. How do we get rid of that, the 5th power? Because remember, in order for you to solve for x or y or b, whatever you're doing, you got to have it by itself. Think about inverses. The inverse of an exponent is a radical. So we want to take the 5th root of both sides. So I need to do the 5th root of that 2,900. So you would find this button in your calculator. If you don't know where it is, help your neighbor. All right. So that button should be right about where your square root button is, or maybe where your square is. And you're going to have to press 5 first because we want 5th root. So 5th root of the 2,973. For you people with Texas Instruments graphing calculators, you have to do the X, or you have to press math. That's the math button. That's 3 down on the left-hand side. Okay, so I need to do 5th root. So same kind of idea, though. You have to press the 5 first. So 5th root of that 2,900. And we get that b is about 4.93 3. We'll say 4.93. Okay? Now the last step here is, do I actually have an equation yet? Well, not really. I got an A equals something and a B equals something. I guess those are just values of variables. So you got to plug those values in to our general form here, and then you got your equation. So y equals 128 parentheses or times 4.93 to the x power. Okay, that is my equation. So if I graph that with an xy chart, I would find out that I'm going to go through that point and that point. Okay? So I want you guys to try the second one here, following exactly the same instructions that I gave you on the first one. Okay? So we want to find, we got to use this formula. And then we got to find A first by using this point. And then we got to find B second by using this point. Okay, so give it a shot. Please pause the video again, 2 to 3 minutes. Let them work through the problem and then resume and we'll go through the solution. All right, so you kind of saw on the first one, if you got 0, 128 or 0, 144 here, A is going to be a 144. And I'll just plug it in here so we can see it. A times B to the 0, so the B goes away. We get A equals 144. Whatever that first point is, if it has a 0 in it, that's always going to be your A. Then we plug in the second point, 21,609 for the Y, and then we have our A as a 144. B we don't know, we're trying to find, but we got a fourth power for B. So you got to divide by 144 and then take the fourth root. So 21,609 divided by 144, we get 150.0625, so I'll just say 150.06 equals B to the fourth, and then you do a fourth root of that function here. So remember, you press 4, then you find your x root, and then you want to do that x root of that 150, and we get 3.5, so that's actually a nice number. Okay, then the last step was actually writing the equation. So we got y equals 144, close parentheses, so 3.5 to the x power. That is our exponential growth equation that goes through those 2 points. Okay? So that is how we find the equation if we're given 2 points. So now let's take a quick break here. So I have some crazy instructions here for you, so don't really pay attention to the instructions, but it's called forward and backward circle. So I'm going to play the video here, and I want you guys to do the same thing that they do in the video. All right? So here we go.
Lower leg out. Right shoulder. And then stop. Gotta go other side.
There's a lot of talking going on, so just kind of pay attention and do what they do. So make sure you're out of your seat, swinging your arms around. This is probably pretty hard for some of you people to do. It's not swimming, their hands are going in alternate directions. Most of the time I just see people swimming.
And the lower leg out and hold.
Okay, so give it a shot.
And then stop.
And if the substitute sees a whole bunch of uncoordinated people that can't do this, they can totally skip ahead and forget about the brain break. But it's about 2 minutes.
Come back up, down, and go up. You gotta do the other leg. So airplane forward. There's that triangle up, back flat, leg up, reaching out. And then back up. And then you go to the sides. It's called side scale. Leg to the left, to the right, reaching as far as you can. Yeah, left leg side. And back up, other side, arms to the left, leg to the right. And then left leg to something. No problem. All right.
Good job, people. Thank you for participating if you did. If the substitute skipped the video because of a lot of uncoordinated people, I apologize. Get coordinated. So that was your brain break. Got a few more things left, and then we'll be good to go. Okay, so we got a couple of word problems here that we're going to try. We got compound interest. Let's actually jump to compound interest because that is more important. If I were doing this one right here, I need to figure out the equation for this. And what we need to do is we need to figure out our x and y. So in 2010, that would be like my 0. So in 2010, that's the beginning time. I have that population. So I would have 1,445,632. And then the second point by 2015, so that's 5 years later, I have this other number. So 1,563,25. So we do exactly the same thing we just did to find the equation. We're going to use this one first, find the A, this one second, find the B. Okay, that's how we would do that with a word problem. Okay, so let's jump to compound interest. So I want you guys to write this formula down. So we have A equals P times quantity 1 plus R over N, close bracket or close parenthesis to the NT power. N is the number of time it compounds per year. That's very important. On a quiz that's coming up, I'll probably give that to you. On the test, you got to know what the N stands for. Right? If you ask me, I'm going to tell you I don't know. A is the amount we're finding, okay, or this was the ending amount. P is the initial amount. That's also called principal. Okay? That's another thing that is called, that's the principal of the loan. So that would be like your initial loan amount, or the principal would be like maybe the amount that you are depositing. R is the rate. N is off to the right here. And T is time. Okay, so just to kind of dissect that formula for you a little bit, break it into pieces so you know exactly what the variables stand for. Let's give it a shot. Try to use it. So the number of times it compounds per year, we're going to kind of put that into some numbers here. So we are depositing $4,000 in an account that pays 2.9% annual interest. So we have enough information to kind of set up a formula. And this is the first thing that we're going to use, and this is going to tell us what our N is. Okay, it's going to compound monthly. You might see stuff sometimes that compounds daily. Most of the time it compounds monthly. But that's how the credit card companies get their money out of you, the way it compounds. So you got to know, if it compounds daily, that's the worst because they're going to get the most money out of you. If you're putting money in a bank and it compounds daily, that's the best. Okay, so it depends on what you're doing. If it's money that you're putting into something, or if it's credit card debt. Okay, so let's set up our formula. We have A, which is what we're trying to find. Principal is $4,000. That's what we're plugging in. Okay, 1 plus my rate. Right here is 2.9. Remember how we set that up? We got to move our decimal place over twice, so it's 0.029. So it's 0.029 over n, which we'll get there in a second, to the n times t. So we are doing it for 1 year. So if we are compounding monthly, n is the number of times per year. How many months are in a year? 12. So that means n equals 12 for monthly. So I put a 12 down there and a 12 right there. So there is a lot of room for errors on this one if you're plugging stuff into your calculator. What you want to do first is this. You don't even need to plug that in your calculator. 12 times 1, that's just a 12. So I'm going to take it to the 12th power. Now you should be able to just kind of plug it in as you see it. So 4,000, use your parenthesis button if you got it, and then 1 plus 0.029 divided by 12, right? Fractions are the same as division. And then take all of that to the 12th power. You should get $4,117.55. If you did not get $4,117.55, then you should probably check around at your table to see if somebody else got it and ask them how they did. Okay? So figure out how we got 4117. Make sure you plugged it in your calculator correctly. And then we're going to try another value for n. Okay? So that means my money was sitting in there for a year, compounds once a month, and we made $117.55 on it. Not a bad deal for money sitting in there for a year. Quarterly is another one that you're going to see. So think about how many quarters are in a year, or maybe quarters in a dollar. There are 4 quarters in a year and a dollar, so that means n equals 4. Okay, so it's exactly the same formula, except the numbers are going to change here and here. So it would be rewritten like this. 4,001 plus 0.029 over 4 to the 4 times 1, which is just 4, because we're only compounding for a year. That's why it's still just a 4 up there. So you can recycle everything that you just put in your calculator, but instead of a 12, you're going to put a 4 in there. Okay? And when you do that, you should get a number that's fairly close to the first one that we have up above here. So we still get 4117, but we get a different decimal here, so it's 0.27 or 267. All right? So that's true, that's correct, because if you think about this dollar amount, $4,000 is not really that much money to put in an account. All right, so the fact that we fluctuated about 28 cents, that's the difference between, because right here we compounded it 12 times in a year, right here we compounded it 4 times in a year. So we just did 8 more times for the monthly one, and the more you compound, the more money you're going to get, or owe, depending on what you're doing here. Okay, so we'll kind of give you a couple more values for n. We're not going to do them all. Okay, so semi-annually, that would be twice a year. All right, so that's n equals 2. These are some things that you could write down because these are some words you're going to see. And then yearly, if you're compounding yearly, that formula, you would just have n equals 1. Another one that you might see is daily. So how many days in a year? That's n equals 365. Another one you might see is weekly. All right, so there are 52 weeks in a year. Oops, sorry, n equals 52. So that should kind of take care of a lot of the values of n that you're going to see. So monthly, quarterly, semi-annually, yearly, bi-monthly, you can see that. That's twice a month. Okay, so we'll write that up there, bi-monthly. Probably don't need the hyphen there, so let's just write bi-monthly. Twice a month, if there's 12 months in a year and we're doing it 2 times per month, that's n equals 24. Okay, so those are the values for n. This formula is fairly self-explanatory, so we're just going to do one of these. We actually did 2 up here, so let's jump ahead. And here's another compound interest problem. If it just says compounded quarterly, then you know you're using, or compounded whatever, you know you're using this formula. Later on, we're going to get to compounded continuously. That's a separate formula. So let's finish with solving exponential inequalities. Okay, the way we solve these is exactly the same as what we did before. The only thing we have to remember is to flip the sign if we multiply or divide by a negative. So let's try the first one and maybe one more, and then we'll call it good. So solve this inequality. We have a 5 over here. Can I break the 5 down at all? Are there any base factors of 5? No. 5 is prime. The 5 to the 3 minus 2x, it does not change. Now this one over here, you're like, holy cow, 625. Well, since there's a 5 on the back end, that's probably got to be a factor of 5. Okay, so let's keep our sign the same. 625 is actually going to be 5 to the, so 5 to the third is 125, 5 to the fourth is 625, but we got 1 over 625, so how can we make that a fraction? 5 to the negative fourth, right? Because negative exponents flip them or create fractions. So we got the same base, let's forget about it, set the exponents equal to each other, and go ahead and solve. So move the 3 over, then we're going to have a negative 2x is greater than a negative 7, divide by a negative 2, and don't forget, because we divided by a negative, that's going to be x is less than 7/2. And you can actually check this one also, because think of what numbers are less than 7 over 2. Well, 7 over 2 is 3.5. So if I plugged a 3 in there, then it would work. So I could check my answers. I could kind of throw some numbers in there to see if it works. Okay, let's try one more. I want you guys to try this, and then we'll go to the homework for the lesson. Okay, so we got 3 to the 4 minus 3x is greater than 1 over 243. Work it the exact same way we just did the one up above. So pause the video, have the students work through the last example here, and then we will get to the homework. Okay, so we keep the 3 the same on the left. The 1 on the right, 1 over 243. So 243, you're going to have to figure out what that is. Well, we know that 3 to the 4th, so 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3, that's your 243. So that's 3 to the 5th. So this would be 3 to the negative 5th. Same deal. 3's are gone. Set the exponents equal to each other and solve. So we get negative 3x is greater than a negative 9. Divide by a negative 3. Flip your sign. Boom, boom. X is less than 3. So we could plug in 2.9. If you wanted to check it, that would work out. Okay? So that's solving exponential inequalities. Exactly the same way as what we did before, except there's a greater than less than sign in there. Okay? So we're not going to do this exit ticket. We'll just jump into the assignment, and here you go. You can work through that. Okay? If you need some extra assistance, you can search YouTube. I would search solving exponential equations, just like the title of the video, or title of the lesson. Okay, solving exponential equations. If you can't find anything there, then you can email me and I can find something for you. Or you can also go to your textbook resources. And you can go to the personal tutor. So that would be the personal tutor for lesson 6-2. That would be another good resource for you because they explain it fairly similar to the way I do. Okay? So good luck with that assignment. Work hard. And I'll see you when I'm back in class.